Hey everyone! Welcome back to Telecom Unplugged with Atul. In our first video, we introduced the fascinating world of telecommunications. Today, we are going to dive into the basic components that make up the telecom domain. Ready to get started? Let's go! So, what are the building blocks of telecommunications? Let's start with three key components: routers, switches, and firewalls. These devices are like the unsung heroes of the internet, working behind the scenes to keep us connected. First up, we have routers. Think of a router as a traffic director. It takes data packets from your devices and directs them to their destination, whether that's another device on your network or a server halfway around the world. Without routers, our data would be lost in cyberspace. Next, we have switches. While routers connect different networks, switches connect devices within the same network. Imagine you are at a party, and the switch is the host, making sure everyone can talk to each other without any confusion. Switches use something called packet switching to forward data to the right device. And finally, we have firewalls. Firewalls are like the security guards of your network. They monitor incoming and outgoing traffic and decide whether to allow or block specific data packets based on predetermined security rules. This helps protect your network from unauthorized access and cyber threats. So, to recap, routers direct traffic between networks, switches connect devices within a network, and firewalls protect your network from unwanted intrusions. Together, these components form the backbone of our modern communication systems. But how do these components work together in real life? Let's use a simple analogy. Imagine you are sending a letter. The router is like the postal service, making sure your letter gets to the right address. The switch is like the mailroom in an office building, sorting and delivering letters to the correct recipients. And the firewall is like the security guard at the entrance, checking IDs and making sure only authorized people get in. Pretty cool, right? Understanding these basic components is the first step to mastering the telecom domain. Going to dive into local area networks, or LANs. Ready to learn how your home or office network works? Let's get started. So, what exactly is a local area network, or LAN? Simply put, a LAN is a network that connects devices within a limited area, like your home, school, or office. It's what allows your computer, smartphone, printer, and other devices to communicate with each other and share resources. Imagine you are in an office with several computers, printers, and a server. A LAN connects all these devices, allowing them to share files, access the internet, and use the same printer. It's like having a mini internet just for your office. One of the key components of a LAN is the switch. Remember from our last video? A switch connects multiple devices within the same network, ensuring that data gets to the right place. Think of it as the network's traffic cop, directing data to its destination. Another important component is the router. While the switch connects devices within the LAN, the router connects the LAN to other networks, like the internet. It's what allows you to browse the web, send emails, and stream videos. But how does all this work in real life? Let's use a simple analogy. Imagine your LAN is a small town. The switch is like the town's post office, sorting and delivering mail to the right houses. The router is like the town's main road, connecting it to other towns and cities. And the devices on your network are like the houses, each with its own address. And let's not forget about Wi-Fi. In many LANs, especially at home, wireless access points, WAPs, are used to connect devices without the need for cables. This allows you to move around freely with your laptop or smartphone while staying connected to the network. So, to recap, a local area network, or LAN, connects devices within a limited area, allowing them to share resources and communicate with each other. Switches, routers, and wireless access points are key components that make this possible. Now, we are going to take a step further and dive into wide area networks, or WANs. Ready to see how the internet connects the world? So, what exactly is a wide area network, or WAN? Simply put, A WAN is a network that extends over large geographical areas, often connecting multiple LANs. It's what allows businesses with offices in different cities, or even countries, to stay connected. Imagine you have a company with offices in New York, London, and Tokyo. A WAN connects all these offices, allowing them to share data and communicate as if they were in the same building. It's like having a global network that spans the entire world. One of the key components of a WAN is the router. Remember from our previous videos? Routers direct data traffic between different networks. In a WAN, routers connect multiple LANs, ensuring that data can travel across long distances. Another important component is the cloud. In modern WANs, cloud services play a crucial role. They provide scalable and flexible resources, allowing businesses to store data and run applications from anywhere in the world. Think of the cloud as a giant virtual storage space that you can access from any device. But how does all this work in real life? Let's use a simple analogy. Imagine your WAN is a global airline network. The routers are like the airports, directing flights, data, to their destinations. The cloud is like the airline's central hub, where all the planes, data, are stored and managed. And the devices on your network are like the passengers, traveling from one place to another. And let's not forget about satellites. In many WANs, especially those covering remote areas, satellites are used to transmit data. This allows even the most isolated locations to stay connected to the global network. So, to recap, a wide area network, or WAN, connects devices over large geographical areas, often using routers, cloud services, and satellites. WANs are essential for businesses and organizations that need to stay connected across different locations. Now, we are going to dive into the role of circuits in telecommunications and see how they enable communication. So, what exactly are circuits in the context of telecommunications? Simply put, circuits are the pathways that allow data to travel from one point to another. They can be either analog or digital, and they play a crucial role in enabling communication. Let's start with analog circuits. These were the first type of circuits used in telecommunications. They transmit data as continuous signals, like the sound waves of your voice. Think of an old-fashioned telephone line. When you speak, your voice is converted into electrical signals that travel through the circuit to the other end. Analog circuits are great for transmitting voice, but they have limitations when it comes to data. That's where digital circuits come in. Digital circuits transmit data as discrete signals, usually in the form of binary code, zeros and ones. This allows for higher data rates and more reliable communication. Imagine you are sending a text message. Your message is converted into binary code and transmitted through a digital circuit. This code travels through various network components, like routers and switches, until it reaches the recipient's device, where it's converted back into text. But how do these circuits work in real life? Let's use a simple analogy. Imagine you are sending a letter. An analog circuit is like a traditional mail route, where your letter is carried by a postal worker from your house to the recipient's house. A digital circuit, on the other hand, is like an email. Your message is broken down into small packets, sent through various servers, and reassembled at the recipient's end almost instantly. In modern telecommunications, we often use T1 and T3 circuits. A T1 circuit can carry 24 channels of voice or data, while a T3 circuit can carry 28 T1s, which equals 672 channels. These circuits are essential for high-speed data transmission in both LANs and WANs. So, to recap, circuits are the pathways that allow data to travel from one point to another. Analog circuits transmit continuous signals, while digital circuits transmit discrete signals. Both types of circuits play a crucial role in enabling communication in our modern world. In our next video, we'll explore virtual LANs, or WLANs, and see how they improve network efficiency and security. Don't forget to hit that subscribe button and click the bell icon so you don't miss any of our upcoming videos. And if you have any questions or topics you'd like us to cover, drop them in the comments below. Thanks for watching, And I'll see you in the next video. Stay connected, stay curious.